for keyword C. The first practical force experiment we are having. In that first experiment is Kater'S pendulum. To determine the intensity of the gravitational field by using the Kater'S pendulum. That is the aim of our experiment. Now here, this is a Kater'S pendulum. You can see the rod is there. On that rod, heavy mass is fixed at the one end. Symmetrically on other side, the wooden mass is attached. These two masses are movable. Then at the center, two small masses are there. One is of steel material, another is of the wooden material. Then two knife edges are there. So this pendulum was devised by Kater, and therefore this name is given to that pendulum as a Kater'S pendulum. It is a physical pendulum. A heavy body is rigid body suspended about an axis, oscillate freely under the gravity. It is called as a physical pendulum. So all of you are aware that. Now this pendulum you will have to suspend. Initially when you start the experiment, you should see that all these masses which are there, this metallic heavy mass, then wooden heavy mass, they should be symmetric about the center of the Kater'S pendulum. So you can change their position, open it, you can change the position of it. This way also you can open it and change the position of it. See that if the metallic mass is here, wooden mass will be on opposite side. On the side of the metallic mass, smaller wooden mass will be there. On the side of the bigger wooden mass, the small metallic mass will be there. Then two knife edges are there. You can change the position of the knife edges. So this is already adjusted. Then there should be a pin attached at the one end. You can see this pin is attached at the one end of the rod, and at another end also you will have to attach the pin. Then your Kater'S pendulum is ready for suspend there. Now take this Kater'S pendulum and you suspend it in the gap here. And here there is a gap. Insert it here properly and put it on the smooth surface which is there, and taking the care that it should not touch on this side or that side, here and here. Then after suspending it, see that it is free to oscillate. The first experimental part of the experiment is to measure the time required for 10 oscillations. You have suspended it about the knife edge K1, you call this as K1. You will suspend it about the second knife edge K2. You have to measure the time required for 10 oscillation about this knife edge. A stopwatch will be given, a digital stopwatch is there. Measure the time required for 10 oscillation about the first knife edge. Then remove this, suspend it about the second knife edge, and measure the time required for 10 oscillations again. So this way, time required for 10 oscillation about this knife edge, time required for 10 oscillation about this knife edge, you have to measure. Now the position of it should be fixed properly, so that in between the experiment its position should not change. And here when it will be suspended and when you will give the oscillation, so let us give the oscillation to it. A very small amplitude oscillation will be given. If the fans are there, you will switch off the fans. Then a very small amplitude oscillation. So here just it will start oscillating, and measure the time required for 10 oscillation. How will measure that? Our telescope is there. Focus the telescope on the tip of the pin and measure the time required for 10 oscillation with the digital stopwatch given. Tabulate it. time required for 10 oscillation about the first knife edge, time required for the 10 oscillation about the second knife edge. Now the principle of the experiment is, this is a center of suspension, then you will find out the position of center of oscillation. The center of suspension and center of oscillation are interchangeable, and the period of oscillation about these two will be equal. T equals to T dash. So what we have to do, we have to make the period of oscillation about this knife edge and this knife edge to be equal. Time required for 10 oscillation, you know, divided by 10 you will get the time period. T1, T2 you will get. Now this is a trial and error method. You may require 10 minutes, within 10 minutes you will get equality, or you may require 40 minutes, 1 hour to get the exact time periods equal. It requires a time. You take care and you try to make the time period equal. Don't try to adjust it, because you know the answer that time period should be equal. But following the proper experimental procedure, now if you measure the time period here, suppose it is coming 1.76 second, here it is coming 1.78 second, the difference is there. Now to reduce the difference and to make them equal, shift the knife edge near to this metallic heavy mass by 0.5 centimeter away. Then once again suspend, measure. Suppose by shifting it by 0.5, the period difference is increasing, means you are going in wrong direction. You take it in the upward direction. Once again measure. If the difference is reduced between T1 and T2 you are measuring, then you are going in proper direction. Measure the time period about it. If they are coming 1.76 was there, 1.7 it was, now it is 1.76, 1.77. Means you are going in proper direction. Once again shift it by 0.5 centimeter. Measure it. Trial and error method. Once you get the equality, tabulate all these. First reading, second, third, fourth, all the readings you will tabulate, and once you get the time period of oscillation about one knife edge and time period of oscillation about the another knife edge equal, then the second part of the experiment will start. What is the second part of the experiment? Measure the time required for 100 oscillation about this knife edge 3 times. Remember that when you are doing the measurement, table lamp should be on. You should use the telescope, focus it properly on the pin, and measure the time period or the period of oscillation about 100 oscillations. Not so easy to measure. Carefully, keeping the eye on the pin, and the timer should be on. And as soon as the 100 oscillations will be over, you should switch it off. One reading, second reading, third reading. We are taking the 3 reading to minimize the error in the observations. Then suspend it about the second knife edge. Measure the time required for 100 oscillation 3 times. Then divide by 100 will give the period of oscillation about first knife edge, second knife edge. After doing this, you will have to remove it. Remove it. Keep it on the knife edge. A sharp knife edge you can have, and put it on the knife edge and try to balance it on the knife edge. Now try to balance it on the knife edge. Pause.